A compound inequality is two inequalities joined either with the word and or with the word or. In the case of and, the solution is the set of all real numbers that satisfy both inequalities at the same time. In the case of or, the solution is the set of all real numbers that satisfy at least one of the inequalities. Let's look at some examples. 2x plus 1 is greater than 3, and 3x plus 5 is less than or equal to 11. X is 1.4 is a solution since it satisfies both inequalities. But x is equal to 0 is not a solution since it does not satisfy the first inequality. Note that x is equal to 0 satisfies the second inequality, but that is not enough to be a solution. It needs to satisfy both inequalities because we have an and inequality. Second example, 3x minus 1 is greater than 2, or 7x plus 5 is less than 4. 2 is a solution since it satisfies the first inequality. Note that 2 does not satisfy the second inequality, but that is okay. In order to be a solution, it must satisfy at least one of the inequalities since we have an or inequality. Note that 0 is not a solution since it does not satisfy the first inequality and it does not satisfy the second inequality. Some compound inequalities with the word and can be combined into a shorter expression using two inequality signs. That only happens when you have inequalities about the same expression. Compound inequalities with the word or cannot be combined. Examples. X is greater than negative 3 and x is smaller than or equal to 5. We can combine this into negative 3 is less than x is less than or equal to 5. The reason we can do this is because it is a compound inequality using the word and it is about the same expression, namely x, in both inequalities. Here this also means that we actually have the solution of the compound inequality already. It is the interval negative 3, 5. Notice a round bracket around negative 3 and a square bracket around 5, since negative 3 is not included, but 5 is included. Second example, 2x minus 1 is less than 3, and 2x minus 1 is greater than or equal to 2. Since these inequalities both deal with the quantity or the expression 2x minus 1, we can combine them. We can combine this to 2 is less than or equal to 2x minus 1 is less than 3. The solution of a compound inequality involving the word or typically consists of two parts. A mathematical notation for joining two intervals is the union notation, a big U. This is just a notation for the word or. Example. X is less than or equal to 1 or x is greater than 5. The solution of the first inequality is the interval negative infinity 1. The solution of the second inequality is the interval 5 infinity. Hence the solution of the compound inequality is the interval negative infinity 1 or the interval 5 infinity. We write the solution using the union notation as the interval negative infinity 1 union the interval 5 infinity. To solve a compound inequality, we must solve both inequalities involved. If we can combine the inequalities, which happens when we have an and inequality and it deals with both inequalities deal with the same expression, then we can solve the combined inequalities simultaneously.